All right. Well, thank you everyone for joining my session today, where I'll be talking about continuous performance testing in DevOps. I want to give you a quick introduction before I dive in. I'm CTO of Utopia Solutions, and my focus over the past 30 years or so has been on automation and testing and performance testing. But relevant to today's topic, excuse me, most of that time I've spent performance testing over the years has been focused on executing big system level performance tests that were really executed at the end of release cycles. And we got really good at that. We took the time to understand the user and load profile, make sure we designed the right test. We set up testing and monitoring infrastructure to ensure that the test was executed in an effective way. And while that approach was very well accepted, certainly you can find similar scenarios in most organizations that had a mature performance testing function. It had one serious flaw, and that realization of that flaw has led me to declare that performance testing is dead. So now hopefully that I have your attention, let me qualify that statement a little bit and add that traditional performance testing is dead. Now, do I really believe that performance testing in general is dead? No, not really. But I needed a controversial statement really to grab your attention. So let me blow up the fine print a little bit and qualify that a little bit further and say that traditional performance testing as the only evaluation of system performance certainly should be dead. So to understand why, let's take a look at what traditional performance testing looks like. It was born out of the waterfall model, where a single cycle stretched over many months. And then after functional testing was completed, we developed and executed a large system level performance test that often lasted many weeks. And I spent a good time, a portion of my career, helping organizations set up centers of excellence that became very effective at executing this type of performance testing. But they always had to enforce the often strict rules that went along with that. Rules that said, if you want me to be able to test your application, it better be complete. Because if it doesn't work in a single user environment, how can I test it under a multi-user load? Your code better be froze while I'm scripting and executing. Otherwise, I'm going to have some additional work to do. And you need to provide me with a production-like environment if you want the results to be meaningful. So this takes us back to that flaw that I mentioned earlier. So let's say we do that. The organization decides to play along with those rules, and we design, build, and execute the system-level performance test, and it takes many weeks before we get any results. What happens if we find issues at this point? Our options aren't good. We either delay release, which means we delay releasing value to our customers, or we get hit by the freight train. And that freight train has lost revenue, lost brand value, lost customer loyalty. And it's also the increased cost of remediation for those issues compared to when they were, or if they were found much earlier. But either way, our options aren't good. And we need to find a way to evaluate the performance of our application much earlier, and ideally as close as possible to the time when those issues were introduced. So the logical approach, at least my first idea to approaching this, was to try to perform this traditional performance testing at the end of each development sprint. The thought being that if I start relatively small and maintain that performance test as we build the application, I can somehow keep up. But of course, it became very difficult to enforce those strict rules that I mentioned when you take a more agile approach to software development. If you wait until new features are functionally complete and tested, there's really not time to enhance and maintain that performance test before the end of the sprint. And we certainly aren't going to freeze code for an entire sprint or worse, multiple sprints. And certainly if we're early in our development, it's probably very unlikely that we have something that resembles a production-like environment. So we end up combining those short agile development cycles with lengthy rigid performance tests, and we end up with disaster. And I stubbornly banged my head against the wall for quite a while, tried to solve the problem of shrinking down those traditional system level performance tests into something that could be executed effectively and efficiently within a development sprint. But after a while, I realized I was solving the wrong problem. My goal ultimately was to get more frequent feedback on performance. But I was assuming that the way to do that was at the system level, like I had been doing for many years. So I started doing a bit of research. And while there wasn't too much information on performance testing specifically, there was a lot of work being done around this thing called continuous testing. And really the rest of this talk is the lessons learned from an almost 2-year journey that I took with an organization as we evolved from a centralized performance testing center of excellence that performed only system level performance tests at the end of releases to something where we could evaluate performance more frequently, more continuously as they built their software. So let's talk about what continuous performance testing is, and probably better to start with what it isn't. I learned the hard way that it's not just more frequent performance tests. It's not just moving performance tests earlier in the development cycle. And it's not just faster or completely automated performance tests, although as we'll see, automation certainly has a big part in it. But it is the appropriate level of evaluation of performance at each stage of the delivery cycle. Is more frequent, more visible feedback on performance. And an important aspect of this is continuously trending that feedback across builds so we can create a continuum of performance data as we develop our application. So let's see how we're doing. If traditional performance testing doesn't fit in agile DevOps cycles, right? But there's certainly a lot of organizations that are building software with a DevOps approach, agile DevOps approach. Let's take a look at how they're doing with respect to performance testing. And now this data here is a bit dated, but based on what I've seen at least, things really haven't evolved much. So according to State of DevOps report, even if we look at elite performers, only 28% are performing some type of automated performance tests or performance testing as part of their delivery pipeline. So if even the elite performers aren't performing or aren't executing this continuous performance testing at a high rate, there must be something missing. So let's see what that might be. And I've noticed that there's quite a few things. First is a lack of performance-related requirements and user stories. If we're not thinking about performance testing from the beginning, it's difficult and probably unfair to expect the team to think about it as features begin to move through the delivery cycle. And really going hand in hand with that is development teams not having the accountability for performance testing analysis, right? Especially in situations where traditional performance testing was handled by an outside team. Similar to that, development teams often lack the knowledge and experience for performance testing. And this is, again, especially true where it was someone else's problem, right? Handled by someone else or another team. And finally, the concept of performance analysis was limited to running large-scale system tests, system-level performance tests. And the organization as a whole just didn't possess the skills or tools required to analyze performance. Again, right, there was probably some other team that was doing this. So what can we do about those issues? I'm going to go through each one here one by one and talk a little bit about how we can address those issues. again, one of the huge holes in most organizations is the failure to think about performance from the beginning. And again, many times this hole was created in older software development processes where understanding the performance of the system was someone else's responsibility. But I found a great way to address this is to consider performance requirements and I'll call them factors when stories are being created. So as you're creating your stories, think about these factors from a performance perspective that are important to that story. For example, let's look at this one here related to the feature that describes the ability customer in various ways. Maybe I know that I have a peak throughput of around 90,000 searches per hour. And given that we need customer account information and the products that they have subscribed to in less than 5 seconds, I know that that has to be displayed to my customer support agents within that time frame. Although I want to mention that one thing that we found when we started doing this, we started calling them performance requirements, and we started to get into a situation where we were kind of paralyzed by the analysis. We were trying to get very detailed description of these performance requirements, and the organization just wasn't ready to think about that information. So we spent a lot of time and kind of created our own bottleneck. But when we started calling them factors and took the formality away from it, just, hey, you've got this story, think about how it may be impacted from a performance perspective. And then things started to flow much better. Of course, at some point, we have to incorporate these requirements more formally in our work. And I've seen this done a handful of ways. Probably the most popular is as constraints, right? Something that all stories, or maybe most stories, must meet. So if you think about performance requirements, response time, support for a number of concurrent users, or some volume of throughput, they often apply to many features or user stories. So as we create these stories, rather than copying the acceptance criteria from story to story, we can just simply link them to these constraints. Of course, we're going to have stories that have unique acceptance criteria related to performance. Perfectly fine to document the performance requirements specifically per story. Before I move on, I want to say that how you approach incorporating performance requirements should fit with the way your organization works. The key is to develop the awareness of the performance factors as you're building the software, rather than waiting for someone else to think about it at the end of a release cycle. So I found the method by which you do that is less important. Just start with what makes sense for your organization, and adjust as you go to find your best way of working. So next, we talked about accountability. And it's not surprising, right, that we see a lack of accountability for performance. There's still a lot of inertia around that traditional performance testing was someone else's responsibility. We talked about awareness, and I believe awareness is an important prerequisite to accountability, right? If our teams aren't aware of what we're trying to accomplish and why, it's hard to hold them accountable. As we just discussed, two important ways to build that awareness are to discuss performance factors and then incorporate performance requirements within the way we work. But we also need visibility, right? Awareness is one thing, but if we're not constantly reminded how important performance is, we're likely going to let it slip into the background. And I found the best way to keep performance visible is to ensure that our definition of done requires us to document those performance factors and performance-related acceptance criteria as part of our stories. I've also seen some organizations create the role of performance owner. One organization even called it a performance czar. And it's important to note that the responsibility of this performance owner is not to own all things related to performance, but rather to ensure that teams were adopting a culture of performance accountability. They were responsible really for clearing the way for performance by providing guidance and ensuring the teams had what they needed from a performance perspective. Accountability is one thing, right? But how can we expect our teams are going to magically have the skills and tools to implement performance-related processes into the delivery cycles? You have to start building that expertise. And I suggest one team at a time. If you're part of an organization that has or had a performance testing COE, you can bring those experts into your teams to start seeding them with expertise. And once a team begins to sustain themselves, you can begin to expand that to other teams. And in parallel, I found it's a good idea to develop a virtual COE that can provide guidance and oversight for performance-related activities. I'm not talking about a heavy process or oversight, but just a virtual community that can work together to share ideas, lessons learned, to ensure continued improvement and growth. You also need to think about bringing the appropriate tooling into upstream environments, not just load generation tools, which may already be there, but also performance monitoring and diagnostics solutions that are going to help you understand more than just the user level metrics. And I found that this has really helped us transition from a situation where performance testing was a centralized responsibility to somewhere where it's now part of the delivery teams. Again, this doesn't mean that everyone on the delivery team is a performance tester, performance engineer, but it does mean that everyone is aware of performance and has the appropriate responsibility relative to their role. So next, I want to start taking a look at what some of these performance test responsibilities might look like as we go down a delivery pipeline. So let's take it. I've set up here a relatively simple pipeline, just so we can start to talk about what we can learn about performance at each stage. So, of course, we can learn about performance in the performance or load environment. This is likely we're going to execute something that looks more like a traditional performance test. But as we'll discuss, we're likely not going to execute that on every build, because hopefully we won't have to. We'll be continuously analyzing performance. Certainly learn about information at the integration stage. This is where we're going to focus on individual components, as we'll see, or smaller groups of components. Tests that can be executed relatively quickly and have few dependencies, or have their dependencies mocked. We'll also discuss how we can learn about performance in production, and not from just a traditional production monitoring perspective, but using other techniques as well. We might even be able to learn something about performance when code is committed, depending on what we're doing. But as we'll see, the key is to evolve to a state of regularly evaluating performance, so it becomes easier to track, right? Regressions much closer to the commit where they were introduced. And the old traditional way of performance testing much less frequently just leaves many possible culprits that require investigation. So let's quickly look at the commit stage. I don't see a lot of organizations doing this, but there are some things to consider. I've even found that there's some tools and libraries that were purpose-built for unit performance testing. This table here is something I gleaned from a relatively recent research paper out of Charles University in Prague that lists the most popular unit test frameworks. But popular, again, is a relative term here. I think they reviewed something like 100,000 Java-based projects and only found that about 3% of them had some form of performance unit testing. There are some important considerations. These should be true unit tests, right? Dependencies mocked. We're just using multiple threads and multiple iterations to gather some performance related data. Also, some important considerations. Probably the two most important here are controlling the length of the test and how results are presented. first tests would have to run too long to get enough data to give a high level of confidence in very small performance fluctuations. Therefore, we need to understand that we're going to detect only the obvious changes in performance, which should be fine for most applications. Second is the absolute value of the results is much less important than the trend from build to build, right? We're not going to be in anything that resembles a production environment at this point. So we just want to trend those results from build to build and see when we start to go in a bad direction. Moving down the pipeline, we can definitely learn about performance at the integration stage. And this is where we've checked in code, unit tests have passed, and now our CI server is deploying the new build into some integration environment. So what does that look like? Well, first of all, it's tests focused on individual components. And these should be your most critical components at first, especially if you're just getting started. Right, we can always scale once we've gained some experience and learned about how to best approach this in our environment. We're still early in our pipeline. We want fast feedback. So these tests really just include individual calls to endpoints that are executed by a small number of concurrent threads for a small number of iterations, just to get enough load and enough data that we can use to trend across our builds. Depending on the maturity of our pipelines, specifically how well you control environment configuration and data, you may want to limit the complexity of these tests and mocking out the dependencies of the components. We should also think about measuring not just response times at this point, but also application infrastructure level metrics by extending our APM tooling to these lower environments. And again, there's some important things to consider. We want to execute these on every build so we can trend the results across time. But similar to unit performance testing, right? These tests are not deterministic like functional tests are, right? So we probably shouldn't have failed tests break the build. And it's also, again, right, these results, less important to think about the absolute results, more important to think about trending across builds. So now the picture that I've painted so far, and we'll talk about the implementation approach in a second, but it's still a relatively mature implementation. I would recommend that you don't go back and try to recreate this immediately in your environment, not because it's necessarily difficult, but more because you want to build it in a way that is sustainable by your organization and provides value to your organization. Most organizations will start with just a single component test, maybe even triggered manually at first, just to get the feel for the mechanics of doing this, the type of data it produces, and how to consume and react to that data. And we'll talk more about that in a minute. So before I move down the pipeline, I want to dive in here a little bit. We just talked about testing performance at the unit and component level, but let's not kid ourselves. For many applications, that's much easier said than done. For microservices-based architectures, it's much more intuitive, right? Certainly at the component level to design test. Each component is likely relatively focused in its scope and identifying its dependencies for the purposes of understanding mocking or service virtualization requirements is relatively straightforward, and they lend themselves fairly nicely to very short, focused tests that can be, that can be run efficiently upstream in your delivery cycle. However, for monolithic architectures, the idea of a component can sometimes get a bit fuzzy, and therefore the ability to execute nice, neat little tests that are focused on a single component can become more difficult. But while you may not be able to accomplish the same level of compartmentalization, there's still some things that we can do in this type of situation. A good place to start is to map user actions to specific areas of interest in the application. This might be a specific process in the application or business logic layer. It could be a specific stored procedure in the database. So rather than thinking about testing from a user perspective, think about areas within the application that may have performance issues or something that you're interested in understanding. Then identify the external inputs that will exercise those areas of the application. And your test script should only include the minimum steps necessary to do that, right? Avoid the traditional end-to-end journeys as much as possible. And certainly for monoliths, the scope of performance tests you can do at this level may be limited, right? Because of the reasons I just mentioned. The tests are likely to be a bit longer, and they're likely to have more dependencies, and therefore the time to maintain them is going to be greater. Of course, the ability to mock dependencies and data might be limited as well and require more setup time. So let's move on down to the acceptance stage. Oftentimes it's common to have an inline environment where additional component tests can be run, or small subsystems of components. And then also that out-of-line environment where more traditional system-level performance tests are performed. For the inline environment, this is likely we're going to be running your automated acceptance and regression tests as well. I recommend capturing end-user level metrics as part of those automated functional tests. And this can be added to most frameworks fairly easily. So typically we'll capture response time, certainly, as well as tapping into the browser level performance metrics and save these off across builds the same way we do the rest of our data. It just gives you a good single user baseline of what performance looks like. Again, you'll ideally be executing your component level tests on every deployment with the dependencies mocked, perhaps. If you've got good control over your data and your environment, I think it's best not to mock them at this stage. But the key is that you're evaluating performance throughout the delivery cycle, right? You can be more selective with the larger system level performance test that you would execute in the out-of-line environment. And certainly for those system level performance tests, all the recommended practices here that we know about that, they still apply. There's really no magic. You need to make sure your load profile, the number of users, what they're doing, their throughput is appropriate. You need to understand the test data requirements and prepared for that. You should be prepared to monitor not only the user level metrics, but the system and infrastructure metrics as well. I have seen organizations execute this level of testing more frequently as part of automated deployment, but it's rare, right? And environment provisioning and configuration, data setup need to be part of that process. And the hardest part really is making sure that the tests themselves are ready for execution and haven't been impacted by application changes. All right, so before I go and talk about testing in production, I want to give a conceptual overview of the process and some of the representative technologies that can be used to put this all together. As you'll see, I've listed some tools here. They're just examples, not necessarily recommendations, just to give you an idea of the types of tools that I see organizations using in this approach. First, we'll start out with whatever we're testing, right? We need to have some tool to generate load and throughput. And remember that we want more than just user level metrics. So ideally, we're monitoring the application and infrastructure while the tests are executing. Next, we'll want to collect the results, both from the load and APM tool perspective, ideally in a time series database. Some of the load test tools do a good job of allowing you to collect results across builds and trend them. Others don't have that view that can be easily created, so we'll dump them to a time series database, right? And then have some mechanism to display them. And of course, we want the entire process to be as automated as possible. And you might be thinking at this point, hey, this seems like a lot of work, and I don't see how I can possibly carve off the time with everything else I have going on to implement this. And you're right, that this isn't a trivial amount of work. And as I mentioned, this was, you're kind of seeing the end result of a 2-year journey. So it's important that you understand you don't have to build it overnight. Again, a good place to start is just executing a few simple component tests that are executed automatically as part of your CI/CD process. But one important aspect of doing the work is that this should be part of your technical backlog, or whatever you call the backlog that tracks kind of your continuous improvement efforts, right? If this is off the books work, and we found this out the hard way, meaning it's just not tracked anywhere, it will not be prioritized appropriately, and you'll just never get to it. Even we had the best intentions, but for a long time we just weren't making much progress because we weren't incorporating it as part of the way we worked. So that was a lot of information that we just talked about. And I want to take a few minutes here just to talk about some lessons learned and around the implementation approach. Again, this was a 2-year journey, and we did a lot of things wrong, and we had to pivot and go in a different direction. And I think that's just that's the DevOps culture, right? But if I can save you some time and at least point out some of the very painful points and some of the lessons learned that are probably going to be more common, I think will be helpful. So I recommend first you start small. A good place to start is, again, running some component level tests on a few of your more critical components. Get comfortable with that process and the tools that it takes to execute, and get the information in a consumable state. You can then work out the kinks and scale to other components and eventually other teams. A big lesson learned that we have when we first tried this, we tried to implement it across a large number of teams simultaneously, and it was just a disaster. While we had the right number of people with the skills that we embedded in each of those teams, they had different sets of problems, and they were, depending on who was in the team, different levels of readiness to accept this, and we just kind of ground to a halt in terms of progress. So when we kind of pulled back, started with the team that we felt was most ready to implement this, we got the process down, got the kinks worked out. We were much more successful moving forward. Make this part of your technical backlog, right? So it can be prioritized along with the rest of your work. From experience, this type of stuff just doesn't get done if it's something the team kind of just keeps in the back of their mind, waiting for some free time. Part of getting comfortable with the process is not overwhelming your team, right? Again, another reason to start small. This is information that the team likely hasn't received before, at least not with any regularity. You need to prepare them so they're not only ready to consume it, but understand it, and most importantly, be ready to act on it. Much of the value of performance testing is in the analysis, and we can't assume that teams possess the ability to understand the data that we're giving them and taking action on it. This is going to be a learning process. And probably, again, we started just dumping a lot of data on the teams, and they tried to keep up, they tried to understand it, but pretty soon they just started ignoring it. And then we pulled back and just started feeding issues that we saw to them. And then we would walk through how to analyze those issues with them. And once they understood the process, they just started asking for more information. We didn't have to push it on them. So a good approach here, again, just feed the data slowly, start with maybe only feeding issues, and then open it up as the team becomes more comfortable. Moving on, you need to take care of supporting factors, right? This isn't magic. You're just not creating scripts and executing them. So are you thinking about your test environments, and are you thinking about how you're configuring them and how you're controlling data in those environments? So are these tests ready to run on demand? Moving on. Thank you. All right. Oh, this was a huge one. I knew there was one more. When we started doing this for this particular organization, we were part of a performance testing center of excellence, and we assumed that we were the experts. We were just going to tell them what to do. But it was also a new way of doing things. And when we started to solicit feedback, both in terms of, what did they understand about performance testing? What types of things did they want to learn? We actually learned some things too. And when we started to solicit their feedback, take that feedback into account, make some tweaks to what we were trying to do, we started to move much more quickly. So as you're implementing this against the teams, ask them, do they understand what they're doing? Do they have any ideas about what we're doing? And as we found out, you're likely going to find out that there's a lot of knowledge you didn't know about within these teams. It just has never been used in that way before. Okay, before I wrap up, let's talk quickly about performance in production. I think most of us are probably monitoring our apps in production, or at least we should be. But testing in production, back when I first got started, you didn't do that at all. You could be thrown out of a room for even suggesting it. But it's fairly common today as an important part of a continuous performance testing strategy. From a testing perspective, the obvious benefit is the confirmation that production can support some expected scenarios, but also allows us to test the entire system, not just what's behind the firewall. And with the wide availability of cloud-based load tools, we can evaluate the user experience from various locations and network conditions, all over the world. And we can combine testing and monitoring to give us specific data we want by executing synthetic transactions in production. Similarly, we should create continuous feedback loops between upstream testing and monitoring to improve both test design and our monitoring configuration. Of course, though, right, testing in production isn't as easy as pointing your test to the production environment. There's some things that we need to do to maximize the benefits we get, but of course minimize the risk because we are in production. One mistake I see, especially from the performance testing side, is creating this strategy in a vacuum, right? Having some performance test engineer just come up on their own with what they're going to do. You need to get input from across the organization so you can put together a comprehensive plan that is safe and adds value. If your app's hosted in a third-party environment, you're going to need to coordinate with them. If you don't, you risk making them mad at a minimum, or likely being blocked because they think it's some type of denial of service attack. Of course, if your app is already live, you have customers, and you need to either find execution windows that minimize the impact, or possibly cordon off part of the environment to handle customer traffic while the test is run on the remaining part of the environment. Next, and this is important, the system needs to know that it's being tested, right? We're in production. We could easily create issues with the business, right, depending on what the application does. So the application should know it's being tested, whether it's seeding tested in production or some other means that the system knows, hey, this isn't a real business transaction. It makes this a lot easier. So if you're building a new system, thinking about this from the beginning makes it a lot easier. If not, you're probably going to have to evolve the system so it knows it's being tested in production. Finally, it's a good idea to eliminate or mock requests to third-party services so you don't unintentionally impact their customers as part of these tests. So, quick wrap up. If you take nothing away from this talk, this is probably the most important points. First, traditional end-of-cycle performance tests just don't work well with more modern software development approaches. Continuous testing is just not more frequent traditional performance tests. It's more of continually evaluating performance as appropriate as you go through your delivery cycle. This needs to be part of the way that your organization delivers software, right? Again, it's not the performance test team that swoops in and executes this. It's executed as part of the delivery teams. You may have performance engineers or performance test engineers that are embedded in some of the teams and perform some of the heavy lifting, but this needs to be part of the way that you work, not some external function that gets performed. Finally, again, start small, get feedback, and of course, important part of the DevOps culture, continuously improve. So let's move on to questions. If we don't get to your questions today, please feel free to reach out to me at any of these methods here. Happy to talk about this stuff anytime. We got any questions here? I don't see any coming in. If anyone has any questions, please put them in the chat. I'd be happy to answer anything. All right. Well, if there's no questions, we can cut it off. But again, please feel free to reach out to me at any of these methods, and I will be happy to talk about this stuff anytime. Thank you.